PMs shouldn't be afraid of asking questions about the code base that you're working on. And that's really one of the unlocks that you get from an agent like Cursor. I think the aha moment was really when we started asking things like, take this paragraph and turn it into one word. What's the label? And that's a classification problem. I do think that it's important to think of like, what does success really look like and how to measure it. And then once you get a little bit deeper into that funnel, then you can start thinking of like, what's a good kind of proxy or representative measure of that a human might grade or label.
Hey everyone, in this episode of Future Proof, we sit down with Aman Khan, who's the head of product at Arize AI. We talk about all things evaluations for AI agents. We talk about how AI product management is changing and really changing the landscape of the role of product management in general. And we also chat about how you should build with the hanging possibility of the foundation models themselves improving a lot. Stay tuned, there's a lot to cover, and enjoy. All right. Hey, everyone. Welcome back to Future Proof. Today, I'm joined by Aman Khan, who is the head of product at Arize AI, which is a platform to develop, observe, and evaluate your AI agents. So yeah, Aman, welcome to the podcast.
Awesome. Thank you for having me. Then I'm excited to be here and talk more about evals and agents.
Absolutely. Yeah. A lot I want to cover today kind of around evaluating AI agents and how AI builders should really think about their product roadmaps and where evaluations fit into that. But I wanted to kind of start, since you've spoken and written at length about just the future of the PM role in general and being centered around AI tooling. So for our listeners who might not be familiar, can you bring us up to speed? What is an AI PM? What does that mean?
Yeah, it's a good question, and it's one that comes up quite often. I like to think of this role as, a PM who's either working on or building around AI systems. So if we like zoom back a little bit, there's always been some sort of like naming around some type of technology that might be booming at the time, like fintech PM, health tech PM. I think what's interesting about AI PM, just to define the role a little bit and what's kind of different from some of those other categorizations, is I think AI is making its way into pretty much every product functionality and feature in some way, shape, or form. If not directly, like doesn't mean that you're building, everything as a RAG chatbot or something like that. But at some point, you're going to be touching some component that is using an API or leveraging potentially an LLM or some sort of language model or model in some way. So just thinking about yourself as an AI product manager that's either building products around those kind of surface areas, thinking about how models work and their interaction with your end product, even if you're not building around that directly, like thinking more on the platform side, which models are being used, are there changes to those models happening or those architectures? And then, of course, also using AI more in your role. I think any combination of those three you can kind of label yourself as an AI product manager, which is interesting because I don't think it's a mutually exclusive term. Like I think you can be an AI product manager and in fintech and in health tech and another vertical. In fact, I think that actually makes you even more powerful because you now have specific knowledge in a domain and you're using AI to kind of leverage the technology even further. So that's how I kind of view the world a little bit.
Yeah, that makes a lot of sense. Like, whether or not you're working on an AI specific product like a RAG chatbot or really any product in any domain, it feels so important these days to really understand what's capable, what the model's capable of, and how that can apply both kind of to your internal workflows and also to your apps. Like I keep seeing people like talk about how like prototyping has gotten so easy. Like engineers, designers, they're just like building prototypes faster than they can show up on roadmaps. I'm curious, like what kind of things you see like these AI PMs now doing that are more or less, now achievable that weren't possible before LLMs.
Yeah, absolutely. I think prototyping is a big part of it too. And I like to kind of give this example. 6 months ago, I would ask, it's only been 6 months actually, I would ask this question. How many people, when I'm giving a presentation or talking to a room of PMs, how many people have heard of Bolt, Lovable, and Replit? And most of the hands would go up. And then I would ask, how many people have actually tried one of these tools? And like half the hands go down. And it was like, well, that's the problem we're trying to solve. We just need more PMs like trying these tools and understanding how they work. And it turns out they're not like really sophisticated. They're not super sophisticated when you start peeling the layers off. Some of them are from more of a deployment standpoint, but like the core tech is it's an LLM that writes code. Nowadays, when I ask that question, I get a different answer. So I ask, how many people have heard of them, heard of these tools, or are using them? Most of the hands stay up. So now I kind of ask, how many people are actually trying Cursor or getting closer to the code and to the IDE layer? And that's usually when I'll see like half the hands go down. Like, maybe some people are like, oh, I've tried it, I've used it, it's on my machine. But I think the point here is less about necessarily PMs need to think of themselves as developers, but rather PMs shouldn't be afraid of asking questions about the code base that you're working on. And that's really one of the unlocks that you get from an agent like Cursor. Like, you can, of course, use it to write prototypes and help you build in the first place, but you can also just use it as the question you might ask the engineer on your team, like that tech lead, that lingering question that you're too afraid to ask in the stand-up. And I think that getting more familiar with using these agents to not only prototype and write code, but ask questions about code, add context, brainstorm, that's really, really powerful. And that's sort of, you have to get into the tools to really get that sense of what's possible with them. So to your point, like, prototyping is definitely one really strong muscle to build, but think of these tools as more like engineers on your team that you can work with before you come back to your team with a PRD. Like, make sure you've stress tested what you actually want to build and maybe the different approaches that you can take as well.
Yeah. Yeah, absolutely. That's super interesting, kind of the notion of PMs being able to ask questions about their code and, not being too shy at stand-ups to like, step into those conversations. Like
No.
I my background is in software engineering before I, stepped into product management here at Paragon. And I feel like it's such an important part of like my background and understanding of like how we can evolve our platform and like what's possible and what's not. But now it kind of sounds like anybody can do that. Like, you don't need a software engineering background. You don't need, formal training in this necessarily. If you can ask the right questions, you can familiarize yourself with the art of the possible, which is very cool.
I had this like thought kind of, sticking in my head recently, which is it's really so much of, I know we're going to talk about like how to measure the performance of these agents when you start building them, but even being able to work with agents and working with these tools, it's like the core skill now is context engineering has all the rage, I think on Twitter and X, but I actually think some of this is just like being able to express yourself. And so I kind of want to like think it's a little bit more of a human term than context engineering. Engineering is great. You should be doing context engineering. But from a human standpoint, like, can you express the ideas in a way, and get feedback and iterate on them? And I think that's really a skill that, PMs get to stress test a bit more with these agents.
Totally, totally. Yeah, definitely want to get to kind of agents in general and evaluating AI agents. Before we jump into that, I'm curious, like, just responding to that, was there a moment for you, like when LLMs like sort of, were becoming popularized and we started getting better and better models where you were like, at work or, in personal life using ChatGPT or Claude or anything else, and you were like, oh, I feel like I understand this now. Like, I feel like I know how to leverage this. And there's like this aha moment, like, okay, I know what's possible here.
Yeah, it's super vivid. I mean, there's been a few moments like that, and then I'll go back and be like, man, I remember that moment. Like, that was crazy at the time. But as you ask that question, like, there is one kind of moment in our company journey that really stood out to me, which is I remember vividly. It was like Thanksgiving of 2022, and for background, I think our history now is we are building for any type of company that has like a black box in their system, whether it's an LLM or a traditional model. But Arize actually used to be what we call like traditional ML, which is ranking, regression, classification types of models, computer vision models. And LLMs weren't really a thing that data scientists or ML engineers would really take seriously when thinking about what type of model to deploy in their system. Like, if you think about recommender systems or Rexus or search, these are super high volume, high traffic types of models that you're really optimizing for inference and really specific tasks like summarization, classification. And classification would live in kind of use cases like fraud or lending, things like that. So when we're building around those use cases for like the first few years of the company's journey, ChatGPT comes out and we start looking at it and playing around with it, and everyone is doing like toy things like write me a poem, write me a haiku. And they're like, oh my God, this thing can write a haiku. Like, it's like really cool, like how it's like, it's like a human, but it knows everything. But I think the aha moment was really when we started asking things like, take this paragraph and turn it into one word. What's the label? And that's a classification problem. Take out, BERT models might sound familiar to some folks, but do entity extraction, take out components or keys from this piece of text. And so all of a sudden, we're like playing around with this. It's Thanksgiving. It's like ChatGPT has just come out. I'm like on the phone with the CEO, and we're basically both typing questions into ChatGPT and dropping them in a Google Doc of like, what can this thing do? So we're like, can it do extraction? We're like typing these questions. Can it do summarization? And that was really the moment where like, oh wow, this is going to go after generally a lot of ML, even predictive types of problems as well, because it's just more powerful than just, generation without like, actually has actually a lot of context in it already, with these larger language models that smaller models couldn't do before. So I think that really sticks in my mind as one where we realized what the potential of this technology was and decided to kind of start moving more of the company towards building infrastructure in that space.
Yeah, yeah. That's a great memory. And it reminds me of like I think around that time when people kind of discovered structured generation before structured generation was really a thing. And they were
Yeah.
just asking ChatGPT to only respond in JSON and they were like, wow, this is a great API.
That's exactly what we did. Now that you say that, that was exactly, we were like, can it do a JSON? And then we would like hit it. And then like, and this was GPT-3. So like
Mm.
it was pretty good, but it would mess up. It would start like we were trying to do things like don't respond in anything but JSON. And it would be like, sure, absolutely. And start doing whatever. And we're like, no, you missed. So like, it wasn't that great at like instruction following, but we're like, we could see the potential of what it could be. So that I think really changed our perspective on the space for sure.
Absolutely.
Yeah.
Yeah. So I kind of want to jump over to the evals conversation, talking about, what, how AI builders should think about guiding their products to do the right things. I think, speaking to these like increased capabilities, one thing that's probably very new to the space since you started at Arize is the idea of an LLM-based judge for
Yeah.
evals. Can you tell us a little bit about that and kind of, yeah, what you're seeing people do with those types of judges?
Yeah. So right around that time was when we also realized, how a lot of these systems kind of work was you were using some kind of, even in traditional ML classification, regression types of models, you have this concept of ground truth. And I'll give like two examples of what ground truth sort of looks like just to contextualize a little bit more. You can have ground truth from some type of output or even a customer support bot. Forget about LLMs. Like if you're interacting with a human, and you're like, did you have a good experience with this human? You can give it a thumbs up or thumbs down, right? And that's kind of instantaneous, real-time feedback in a lot of ways. There's also ground truth in the insurance industry, which is when we give out a loan or when we give out a policy, it can take a really long time for us to get signal back of is this person going to default or was this policy correct or not to kind of provide. And what's interesting about these kind of two domains is there's like a time component depending on the type of ground truth you want to collect. And that time in business terms means value or money, right? Like the faster that you can get ground truth or signal, the better you can make your models and the faster you can iterate ultimately from what you're seeing in the market. So with what's kind of interesting about these like LLM agent-based systems is when you think about like what the outputs look like, they're very human gradable in many ways. There's you can look at these things and reason, would a human have given a similar response or not, or what should the correct response have been because it's natural language, and that's also distinctly different than a scoring model where a regression model, which is sort of kind of think of it as like plotting a line on a chart and trying to predict a value, and that's like a score. Like that's a law of large numbers. You're trying to get a score. So is zero point 0.7 the right number or not to put here? Like that's not very human ground truthable, you can kind of put it. So that's what's kind of distinct and unique about these types of models and the applications being built around them is because you can, you can look at the generation and a human can very quickly discern, good or bad, generally speaking, for a lot of these applications. That means that signal is really, really valuable for iteration. So there's kind of those two dimensions. It's like the time component and the fact that a human can kind of take a look at the signal. But if you can kind of build proxies for that type of eval or that type of metric of a human looking at something and giving a label or signal back, then you've cut down the cost and sort of time for iteration even more because you can scale up the signals that you're getting because human labels are rather expensive. Like you're not always going to get thumbs up, thumbs down from an end customer. Having a human look at every single response takes a lot of time and a lot of energy. So that's where it kind of naturally made sense for us to start thinking, okay, well, if our customers are building around these LLM-based systems and they generally are generating text that humans can take a look at and grade, then can we build an LLM grader around this? And so we actually built one of the first open source packages to do this. It's still a function that lives in our code base today. We call it LLM classify. There's another version of it, LLM generate. And these are open source sort of functions to take input data, like in the form of a data frame or a table, really, and provide an LLM judge and give you a label based on some criteria. So it's really those three things. It's like input data, the prompt template, and an LLM that you're using for generating a label. And then I think a really important note here that a lot of people kind of get wrong when they're thinking about eval systems is it is generating a string, not a numeric or integer value. And for folks listening to this, like the reason why that's still really important today is go ask O3 2 plus 2 equals, and you're going to see a ton of reasoning tokens. And the reason for that is because LLMs, when you think of what a token is, it's 4 characters. And so numeric kind of values, LLMs are still not great at processing and generating without tools like calculators. So you still want to rely on natural language, again, expression of like what's a good label and defining that label. And you can have it, generate multiple labels and map those back to scores. But I think that those properties make up a really solid foundation for you to get started with an eval system that you kind of want to align it to what a human would grade the output with. And then once you start having that foundation, you can really start thinking about scaling things up and looking at data and making sure that you kind of trust this type of system to go off, in production as well.
Got it. Yeah. So by text labels, I'm kind of thinking, we're talking about like friendly or not friendly, or maybe there's like a gradient of words that you'd want the LLM to possibly bucket this interaction as, or like helpful, not helpful, like on topic, not on topic, that sort of thing. Am I thinking about that the right way?
So that's Jeff, definitely like a great place to. I think that's still really useful and great place to start. That's where like thinking about these things as like classifiers is really helpful. Like just in the same way that a human would take a look at text and say like helpful, not helpful, or is this generation correct or not correct? And to layer in like what else you can do with these things. Like if you have a human label or sort of let's kind of simplify it even more. If you have context that was given to the LLM system at the time of generation, you can even grade, did the agent use the context correctly or is it hallucinating from within its own weights? And we call that a hallucination eval. So you can add a variable, for basically any type of context you might be collecting at the time of generation that could be valuable signal for this LLM grader to give you that label. So yeah, I think like starting with like human readable, like understandable things is a natural starting point. And then as you think about, wait, we actually have this piece of context. Can we use that to see if the agent is using it correctly? Another example is tool calling. So as you give LLM systems access to skills or tools to use in your agent, you can assess did it use the right tool, and that's sort of grading the reasoning in the first place. And you can build an LLM as a judge or grader type of system to look at the tool selection and determine did the LLM or did the agent use the right tool? Did it reason to pick the right tool in the first place? So what you kind of get is a scorecard at the end of the day of how well your system is performing across things like business logic and like did it take the right actions based on what a human would have done in this situation potentially, or if it's in a pipeline, like was the output correct or not? And then you can do more subjective measures like tone and kind of correctness or helpfulness as well. So you actually have, again, kind of 2 dimensions you can branch off into, like kind of more business logic and then more subjective kind of measures as well.
Yeah, makes a ton of sense. And I imagine like because a lot of these eval outputs and scorecards, as you call them, are just naturally readable just
Yeah.
based on the outputs. I imagine you also think that this is something that the AI PM should, maybe one of their core responsibilities now or in the future. Yeah, tell me a little bit about like the human labeling side of things and like how you see AI product builders, like how can they best leverage their time in terms of like in this evaluation space?
Ooh, that's a hard question. That's the prioritization question coming out of the product. Like you have so many things you could be doing. So how do you kind of maximize your output in this part of the sort of cycle product development cycle? I think it might be helpful to do like a quick like step back in terms of just to hit home a point really quick, which is these LLM based systems, the input to your agent at the end of the day, like if you're building that customer support agent, for your company or at your company, or you're building some type of end interface, even if it's code generation in some way, then at the end of the day, it's really important to think about what that end interface looks like for your customer. Because when you think about what that surface area looks like, you'll start getting like ideas as a product builder of what are the ways that this thing could fail? What are the ways we could get signal back? And so starting there at the very top level is really, really important, even before you get into the things, to start writing evals in the first place. Like, what are the things that determine the success or failure of this product in the first place? And really thinking deeply about that. And I think that's where a lot of like, part of what's interesting about you see these AI engineers, the agents that you're seeing today, a lot of them have been built by AI engineering teams because you have access to the tools. You can just start building agents really quickly. But I do think that it's important to think of like what does success really look like and how to measure it. And then once you get a little bit deeper into that funnel, so that's like step one, like what does product success look like? How would you quantify it? What's the metric you want to go for? Then you can start thinking of like what's a good kind of proxy or representative measure of that a human might grade or label. And that's where I think that there's, again, potential for, in the same way, if you're an AI PM, you're probably going to be involved in the agent development itself. And if not, I highly recommend that you kind of include, think about the architecture as a whole, what the prompts are, and expressing that end product experience. Because again, it is a lot around expression and defining what the agent should do. And you can apply that same thinking towards eval systems too. So now that you kind of have a metric in mind, okay, here's generally how I want this agent to perform a task. You can start breaking that down into what should I measure using another agent potentially, or another eval system, which is also just going to use natural language as well. So maybe coming back to it, like the components that are really important, there's ways to collaborate with your AI engineers as part of this experience as well. So once you find the end product experience, the metric, you're starting to think about evals. That's where I would recommend really being in the room, labeling data, and looking at data both from a development and production lens, and thinking, okay, is this good or bad? And if you're not the right person to label the data, if you're not the subject matter expert, making sure that you have the subject matter expert in the room, and make sure you have good quality data to iterate on top of, is maybe the most important thing you can do when you actually get down to writing evals. And then once you start getting the right data in place, being involved with that prompt iteration sort of journey, and really feeling the pain of trying to build a system that resembles what a human would be able to kind of evaluate, I think will give you a ton of empathy for your engineering team. Believe me, they might be a little bit like, why are you doing this with us? Like, this is the engineer's job. But I highly recommend PMs get closer to that part of the code, because that's what determines whether or not your product is going to be successful.
Yeah, absolutely. I love that. And it's a very first principles way of looking at it. And just, don't do evals just for evals. I mean, do evals in service of an actual product objective. It makes a lot of sense. You kind of touched on this, or alluded to it at least, prompt iteration. I'm curious, like, if you get this is something that I've just been thinking about a lot. Like,
Yeah.
if you get a bad evaluation or your evals are not looking ideal, where do you have like kind of a playbook for AI builders about where to start iterating? Because there's so many variables that you could tune. Like there's prompts, there's like the tool selection. Of course, the agent architecture matters a lot as well. You could go as far down the rabbit hole as fine tuning, although that seems like an extreme option. Curious, like where you stand on that. Like where do you kind of start to iterate?
Yeah, great question, Ethan. I think this one comes up a lot because we're still trying to find, people are still trying to find the right language for what the components of these systems are in the first place. That's something I'll kind of say and I kind of advocate for is there's this term I like to use called AI intuition. And it's a lot like when you're looking at, a software product or a hardware product and you're like, huh, that's how they built it. That's probably how that works. And I think the more that you have that intuition, the more that this answer will, that answer to your question will sort of start to come naturally based on your use case. So the first thing I kind of advocate is like take a genuine curiosity and interest in successful products that you admire that are maybe AI based and try to peel them apart, understand how they work. Once you kind of see what those components are, you'll kind of find that there's like, I don't want to call them tricks, but there's like hacks or techniques that tend to kind of win out over others in a lot of ways. I'll give you one example. There's a repo of, sort of, it's called like leaked system prompts. It's on GitHub. No idea if this is real, by the way. Please do not, I don't want to attach my name to this. I don't know I don't know who leaked this stuff. I don't know if it's real leaks, but it is interesting regardless because what it kind of shows is like you have Bolt and Cursor and Grok have their system prompts as well that people can get access to. You kind of see like there's a lot of secret sauce in the prompts themselves. And okay, if you start thinking about this again, I like that, I do think that this is sort of first principles because there's two types of sort of knowledge that LLMs can use to answer questions. There's parametric knowledge, which is in the weights, and then non-parametric knowledge, which is context. And if you assume that you're holding the model constant, which you are in this case, and let's forget about fine tuning for a sec, you just have a model, what data goes into it determines a lot in terms of what the output is. So that's where the idea of can you change the prompt and evaluate what the output looks like and tweak it. So changing parameters in the prompt, parameterizing your prompt iteration in the first place. Can you change what context goes in? Can you change the tool calling? And the short answer, actually, I guess a longer answer to your question, which is like, what should you go do? Is I would recommend setting up a system or a platform to help you iterate really quickly across all of those dimensions. Because you're going to find that based on what you're trying to solve for, some of those tools are going to be better to use than others. But what you really want is a system that allows you to experiment with ideas really quickly. And that's where concepts like observability and evals can be really powerful because they give you a playground to go and experiment with changing, having 5 different versions of the prompt, trying 5 different versions of chunking or RAG, trying 5 different tools. And you can now get a lot more signal from those types of experiments. So that's my suggestion is like, before you even start iterating, make sure you have the right system in place to iterate.
Yeah, absolutely. Yeah, it does seem like sort of the iteration speed or the cycle time for someone to get results from that type of tweak is super important and yeah, meaningfully impacts how quickly you can improve your agent. Um, I assume that not all of our listeners will have built their first eval for an AI product. I'm curious, like if you have a recommendation on sort of like the first eval or the minimum viable eval that you might recommend that someone writes. I mean, obviously it'll be domain specific, but I'm curious if like having seen a lot of Arize customers like go through your platform, like what is there a common theme to the first evals that they end up implementing?
That's a really good question. I think I'll maybe give like a bit of a cop out answer and then like a short just suggestion on that. The cop out answer is like there's so many different ways that people are using these tools that it's really hard to pick like one specific eval that stands out as being really powerful because it depends on having the right data and context in place. That being said, I think the aha moment for a lot of people with evals, the tone evals are cool because you can align with the human and you can say, oh, this is friendly or not friendly and adjust the tone and see it change instantly. And I think that that's really powerful, but it's sort of like it's a little bit of like a so what, to some degree, in the sense that it's almost like too easy. Like you can, if you just add that one line, you'll get a completely different answer. I think what's actually potentially more powerful and interesting to some degree is when these systems can sound really convincingly correct. And it's like you see the answer and the output and especially in domains that are really specific for, in terms of the knowledge that they might be using, internal Q&A or question and answering or a specific, sort of domain like some type of science or legal or something that's using a lot of context that is very specific, being able to catch when the LLM is answering really confidently, but completely misinterpreting the context is really, really interesting. And it's actually, I think it's sort of an aha moment because we kind of see it happen all the time when you're using coding agents or even ChatGPT. You know that when I'm sure everyone has experienced you are absolutely right, like type of response, right? Like it's like you just lied to me and I caught you in the lie and then you told me you're absolutely right. So this type of eval where you're catching hallucinations in real time is usually where people are like, oh crap, I wouldn't have been able to catch that myself. That was so persuasive. And the takeaway actually from this story is even more than sometimes just having a label, a really important extra parameter you want to add to your evaluations is explanations. And explanations are, think of those as sort of reasoning tokens. We actually hard coded that into our package with the flag. So you don't have to use O3. We had reasoning tokens even before O3 because what you would basically do would tell the LLM, think really, really hard about what the answer should be, gives you an explanation. So when you get the label, you can check the explanation and see why the LLM gave that label. And that's when things usually start to click.
That's super cool. Yeah, that the fact that you can kind of adapt those reasoning tokens to kind of justify the result of the evaluation. That's something we probably, didn't have before in traditional evaluations. So that's like a super powerful tool,
Yeah.
both for, PMs and engineers.
It's super. I mean, generally, it's like it's way more expensive to get human reasoning tokens than LLM reasoning tokens.
Right. Yeah. Yeah. That's a funny way to put it. I like that. Maybe as kind of a last question for you, and maybe this is a hard one to leave on, but I'm curious like about unfixing that underlying model aspect of it. There's sort of like expectations from generally AI companies today that the underlying model will improve, and I think many listeners of the podcast might be curious about like how do we adapt to like the future when the model does improve. Like, to what degree do you think that having just a far more capable reasoning model or something like that solves some of these sub problems that people are building today? Like let's say like prompt optimization or context optimization, things like that. And yeah, how would that influence like your prioritization, your personal prioritization about how to build AI products?
Yeah, if I could try to like maybe try another framing, but the first thing that kind of comes to mind is like, I'm just gonna wait until the model gets better before I go build this feature or product. I think that's something that comes up a lot, especially large companies that are trying to figure out how to invest in this tech. They're like, we're just gonna wait. Like, we'll wait until the model gets better, and then we can go solve this problem. Or like, yeah, we have a team trying to do something, but they're not going anywhere with it. I think there's kind of two things to think about here, and there's in this type of system, there's like the model layer and how good the model is going to get, but then there's also the infrastructure that you need for everything else. So when you think about the model layer, what's interesting is like, I think these models are pretty dang good. Like I'm not, I'm sure I'm pretty confident at some point we're going to get even more capable models, even smarter models. But when you ask yourself the question of like, wow, I have models that can write an entire code base in like 5 seconds and get it like pretty much right on the first single shot. And this is like the use case people are using it for. Why don't I have like flying cars and all these other things? Like that's sort of like what people are like, wow, these things are so good at this one thing, but they suck at all these other things.
Mm.
And or they're just not good enough yet is probably more correct framing. And I think that on the model layer, there's a sort of related story, which is you mentioned you live in San Francisco. I'm positive you've taken a Waymo, like at some point, right? And like Waymos are the result of using a lot of training data to build really sophisticated models for more and more specific scenarios. But underneath the hood, it's not just model level work. There's actually a lot of kind of scaffolding and infrastructure to take data from the real world and use it for training the Waymo. So an example is, I used to work at Cruise in the self-driving space, and back when I was there, the car would be able to drive straight, for like a little bit before a human had to take over. And then eventually you get enough training data and the car can make a left-hand turn. Eventually the car starts to make left-hand turns like 99% of the time. but then a human will come into the sidewalk. And again, like this sort of safety driver had to take over. And now you've got this data set where like 100% of the time, 99.99% of the time, it can drive straight fine. It can make left turns fine. And then a human comes in and it messes it up. And then eventually it gets really good at driving with humans in the sidewalk too. This is what a deep learned system kind of looks like. It uses data from the real world and keeps iterating. But underneath the hood, what is actually happening is these systems are using that real world data and scoring algorithms to build out data sets that can be used for more and more specific scenarios. So the way that this relates back is like, even as the models get better and better, we're going to use them for more and more complex tasks. And eventually there will be some point where you're like, this thing, we already experienced it today. Like we were talking about GPT-3 and now like how capable the models are compared to now. It's like looking at an old version of the iPhone. Like this old tech doesn't even work the way I want it to anymore. And I think it's going to be similar where we're going to expect more from these agents. We're going to throw them in more complex problems and they're going to fail in more kind of interesting and different and challenging ways. And that's where I think the component of having the right infrastructure to catch those failure modes and learn from them is what will differentiate successful products from non-successful products. And so I think it's really, you should bet that the models are going to keep getting better when you're thinking about your product. You just got to make that bet that there's money going towards that problem. But you should also bet that you have the right systems, processes, and tools in place to learn from real world data to keep iterating as the models get better themselves.
Right. So thinking of the model as kind of one, maybe central component of your product, in the fact that it can be the reasoning engine behind the other supporting functionality of your product, but really like without the other components added on and the scaffolding around the model, it doesn't solve your domain specific task in the way that you want to see it or observe it or evaluate it with. So yeah, it makes a ton of sense. And I think that's a fantastic framing for the AI builders that might be listening to this. So really appreciate that.
I think I've never been more optimistic of the potential of this tech. And look, I think it's a super exciting time to be a PM. Like I'll just plug, I think it was, Andrew Ng said this like last week or 2 weeks ago at the YC startup school, which is like, we're PMs are the bottleneck. And so I think if you're a PM and listening to this, he's a pretty great quote where it's like a realization that like PMs are actually sitting in the sort of critical path. And so knowing what to build is really, really critical as well. So I think it's a pretty exciting time to be in the field for sure.
Awesome. Well, Aman, thank you so much again for joining us on the podcast and offering your perspective. I think this has been super valuable for AI builders. And for those of you who might be listening, check out Aman for all the resources he has on AI PM and also Arize for your evaluation needs for AI agents. So thank you again, Aman.
Thanks again, Ethan. This was a ton of fun.
Awesome.
Bye.
Super interesting conversation with Aman. I think that for someone who is working on an AI evaluations product, I think he's incredibly insightful about the first principles approach that PMs should continue to take. We talk about this funny quote that Andrew Ng has about how PMs are currently in the critical path or the bottleneck for a lot of product development. And that's true, but I think product managers and product builders generally have this opportunity to really realign all of the AI building that's happening with the actual business needs that they need to solve and make sure that they're also able to achieve the goals of their customers and end users. So beyond just creating evals for the sake of evals, I think evolving beyond that and making sure that AI PMs can build evals that really reflect the goals of their customers is super interesting. And yeah, had a great chat with him about that and just how AI builders can generally adapt to all of the changes that are happening, whether that's to agent architecture or context engineering or the underlying models themselves. I think there are so many just factors in this space that you could iterate on and tweak as you build your AI product. But I think Aman has a really great perspective to share on how to think about those things, even if all of those things change in the future, which they do, and they could right after we record this podcast. Yeah, a ton of things to consider and lessons learned from someone who's been building products in classification and evaluation for years. Thanks so much for watching. If you found this helpful, consider subscribing to us on Apple Podcasts, Spotify, or YouTube to get all the latest episodes. And to view our past episodes, visit us at useparagon.com/futureproof.